Hello everyone, welcome to another video on the precise definition of a limit. I am still looking at the cubic function. Now this looks a little bit more challenging than the previous one. So we have here, using the precise definition of a limit, prove that the limit as x approaches 1 of x cubed minus 2x squared plus 5x plus 1 is equal to 5. Now I want you to substitute 1 into the place of x and see if this simplifies to 5. Let's try it. If you put 1 here, 1 cubed is 1. 1 squared is 1. So this will be minus 1. And minus 1 would cancel that 1. And if you put a 1 here, it will be 5. So the whole thing simplifies to 5. In other words, 1 minus 2 plus 5 plus 1. So 1 minus 2 is minus 1. Plus 5 is 4. Plus 1 is 5. Now, we're supposed to use the precise definition of a limit to prove that this is true. So naturally, we copy this. And today, I want to move straight into the precise definition of limit without stating the actual precise definition of limit, but incorporating this into the precise definition of limit. Let's see if you can follow it. So we're going to say the limit as x approaches 1 of x cubed minus 2x squared plus 5x squared plus 5x plus 1 is equal to 5 means for every epsilon greater than 0, there exists a delta greater than 0 such that if the absolute value of x minus 1 is less than delta but greater than 0, then the absolute value of the function x cubed minus 2x squared plus 5x plus 1 minus the limit should be less than epsilon. Now we're moving on straight to the 4 steps. Step 1, we state what we're given. What are we given? That epsilon is greater than 0. Step number 2, the choice of delta. I told you that if this function here is not a linear function, delta will be minimum. We want the distance to be within 1, so 1 comma. We're going to choose an expression here in terms of epsilon. Step number 3 will be the assumption step. So assume, what are we assuming? That this part here is true. So we assume that 0 is less than the absolute value of x minus 1, and that should be less than delta. We assume that that is true. Step number 4, I call it the notice step. What do we notice? We notice that this expression here always simplifies to something that we can easily work with. So x cubed minus 2x squared plus 5x plus 1 minus 5 simplifies to the absolute value of x cubed minus 2x squared plus 5x, and this 1 minus 5 is minus 4. Now there is a mountain. So I want to show you something here. That when you simplify the expression, this expression here coming from there, whatever you end up with is always a multiple, or a multiple, yes, is always an expression in which that can divide. So I'm going to use long division to divide this into that, so that I'm able to factorize this as follows. So I'm going to use long division. Let me use another page here. Let's use this page here for our long division. Long division of what? Of this x minus 1 dividing into x cubed minus 2x squared plus 5x minus 4. So we take x into x cubed. The answer is x squared. X squared multiplied by x is x cubed. x squared multiplied by minus 1 is minus x squared. Then you subtract. This minus that obviously is 0. But here you have minus 2x squared minus x squared. So this will change that to plus sign. And minus 2 plus 1 is minus 1. So this is minus x squared. Drop this expression here, there, 5x. Then you take x again into minus x squared. The answer is minus x. Take minus x multiplied by that is minus x squared. Take minus x multiplied by minus 1. The answer is positive x. We're subtracting. This cancel obviously. If you check minus 1, minus times minus is positive, and these two cancel. That becomes minus. Minus times positive is minus. Remember here, times positive is minus. What is 5 minus 1? Is 4. So we have 4x. Drop that one there. Minus 4. X into 4x, the answer is positive 4. Positive 4 times x is positive 4x. Positive 4 times minus 1 is minus 4. Now you can see these cancel. And the answer is 0. So we are looking for this one and this one. Because this is a divisor and that's a quotient. When you multiply these two, you get the dividend, that expression in there. So it means that this can be factorized as follows. Nice stuff. So it means now we have something that is very nice to deal with. Very easy to handle now. Now we are saying this is the same as absolute value of x minus 1, remember, times absolute value of x minus 1 times this expression here, which is x squared minus x plus 4. Like so. Right. Now, this is good because now we can move on to our next step. That says, well, now we're coming to this step here. Which step? We're coming to this step now that says, if I may take this expression here, now we're coming to this part. Let's take note. This page is misbehaving here. All right. Now we're coming to this part here that says this is equal to absolute value of x minus 1 times absolute value of x squared minus x plus 4. Now, this obviously, if you check this one here, is that part there. Absolute value of x minus 1 is less than delta. So this will be less than delta times absolute value of x squared minus x plus 4. Like I did in the previous example, what are we saying? If you allow me to write it, I think it has to be on the same side here. We want distance to be within 1. So the distance between x and our value of a should be within 1. So now I'm going to say we want x minus 1, absolute value of that, to be less than or equal to 1. What does this mean? This means x minus 1 is less than or equal to 1, but greater than or equal to minus 1. That's the definition of absolute value. Then I'm going to add 1 here, there, and there. Adding 1 here, I get 0, less than or equal to. Adding 1 here, I get x, less than or equal to. Adding 1 there, I get 2. Where are you going with this? Well, I want to produce this one here. Now, when I look at the coefficient of x, there is minus 1. I divide it by 2, I get minus half. I'm going to add minus half here, there, and there. Please take note of that. I'm going to repeat. The coefficient of x here is minus 1. Divided by 2 is minus half. Minus 1 over 2 is minus half. I'm going to add there, there, and there. So minus half plus 1 plus 0 is minus half. Less than or equal to. X plus minus half is the same as x minus half. Less than or equal to. 2 plus minus half is the same as 2 minus half. Simplifying, this is minus half. Less than or equal to x minus half. Less than or equal to, what is this? This is 3 over 2. Now I have to square. I have to square that expression now. If I square that expression, I'm going to get squaring minus half. I'm going to get 1/4. Less than or equal to, if I square this part here, what I mean is if I say x minus half and I square that, this expression gives me x squared minus x plus quarter or plus a quarter. And this will be less than or equal to, if I square that, it will be 9 over 4. Now I'm getting somewhere because I see x minus 1 here, x squared minus, I see x squared minus x, which is this part here. But I have a 4, so I have to get rid of the minus quarter, get rid of the quarter here. Subtract quarter there, there, and there. Removing quarter here, I get 0. Removing quarter here, I get x squared minus x. Removing a quarter there, please convince yourself. 9 over 4 minus a quarter, the answer is 2. If I may just help you over here, 9 over 4 minus a quarter. We're saying denominator is the same, that's 4. 9 minus 1. What is 9 minus 1? 8 over 4. And what is 8 over 4? 2. So take note of that. So there it is. Now I'm going to have to add 4 throughout because I need to have a 4 there. So that will be 4 less than or equal to x squared minus x plus 4 less than or equal to 6. Fantastic. Now if I take absolute value now of every term, absolute value of 4 is 4 less than or equal to absolute value of this expression here. I'm going to get that. Absolute value of 6, there is what I'm getting. This is the part I'm interested in. So now I can replace that with that, but our sign now becomes less than or equal to delta times 6, which is exactly 6 delta. And if we set 6 delta to be equal to epsilon, delta will be equal to epsilon over 6. Bring this one here, this will be 6 times epsilon over 6. The 6 is cancelled, and then you have epsilon, and that should be the end of the proof. But remember, we said distance here must be within 1. So I'm going to take epsilon over 6, bring it here, epsilon over 6, and we are saying we're going to look for the minimum of the two, which should complete the proof. All right, I hope you enjoyed this one. It was a bit more challenging than all the cases we've looked at so far. Now I can comfortably say that I have 2 more examples coming up on the precise definition of a limit. I'll be focusing on the radical function and the rational function. Those are the 2 I would want to call them most difficult on the precise definition of a limit. But someone can say, no, but this one is more difficult. Well, it's my opinion. All right. If you're new to this channel, please share these videos with friends and colleagues. It will help us build the channel and grow it. Like I always say, it will give me the impetus and momentum to be able to produce many more videos. I can't wait to start looking at limits, techniques of limits, and techniques of integration. Most students have been asking me, when are you going to start dealing with integration? So we will attend to integration. Basically, calculus is a branch of mathematics that focuses on 2 main areas: determining the gradient of a tangent to a curve, and also determining the area under a curve or a function. So we're going to look at those things in the other videos that I'll upload here. All right, see you next time.